Okay. Hey. First. Okay, hey. Shh. All right, today, unit circle. Where's my cursor at? Where is it? Come on. Oh, there it is. All right. Okay, unit circle. We use this a lot in that homework unless they had tangents. So, if your problem asks for a tangent angle, shh. If your problem asks for a tangent angle, you have to make sure that you're setting up your special triangles in whatever quadrant that angle sits, and then you have to use the actual special triangle to do it. Okay? What?
Need this today?
You needed that for the homework for sure. That we're going to use in the first part of the notes today, so you might want that out. Okay? Second, on your property sheet, the formulas we were using, we had these marked I think last Wednesday or Thursday. I think it was Wednesday. On your property sheet, we should have had a box around these. These are the ones you were doing on that page 603 homework. Okay, you're adding angles, subtracting angles. Sometimes they gave you this to start with, and they gave you very goofy numbers. I think one of the problems I remember somebody doing was there's 40s and 20s in the problem. 40s and 20s. And then you were taking it back to the original problem and then solving it from there. Today, we're going to do a few notes. We have some brand new formulas we're going to talk about. But if you haven't already, and if you didn't hear Larson, you need to have this out that we made last week. If you didn't make one of these, too bad, so sad. You might need to copy one from somebody next to you, or you're going to have to forego not having it for right now. It definitely will help. Today, we're going to use this to help us out figure out a couple formulas today. We're doing double angle formulas today, which all you need for right now is this. This is all you need in front of you, and your notes, obviously. But everything else can be put away, including your property sheet. We'll come back to this maybe at the end of class day, not at the beginning. All right, here we go. So in your notes, and I'm going to walk around, I'm going to check to see if people are actually doing this correctly. Here's what we're going to do. We're going to actually talk about how to derive the double angle formula today. So we're moving on to section 5.3. And today's topic is double angles.
You don't listen. You don't listen.
And we're gonna do a couple examples to talk about that it does work and we can actually prove it, all that good stuff. So the first example, we're going to talk about how they actually derive the formula. So we're going to actually have you guys actually work it out and see what the actual formula is. So this is kind of weird. Usually I always give it to you and I just tell you what the formula is and we use it. Today you have to actually find it before I'll let you use it. So here we go.
Why can't we just use it without finding it?
Nope.
No.
Doesn't work that way.
But did somebody already derive it?
I haven't derived it on the board yet. You guys have to find it yourselves.
But didn't they derive it?
Yes.
Somebody did.
Somebody did. All right, here we go. Hey, here's what I'd like you to write down. Cosine alpha plus beta. I need somebody right now to tell me that formula from that little handout we did.
Here, I got you. Cosine of alpha times cosine of beta minus sine of alpha minus sine of beta. I really hate that I had to memorize. I didn't even use my sheet, Mr. Ward, I memorized that.
Nice. All right. Here's what I'd like you to do. Here's what I'd like you to do. I'm waiting you guys out until you stop talking. Seriously, that group, you're not going to stay there today. Here's what I'd like you to do. Take beta in this formula right now. Take beta out, replace it with an alpha. Take out beta, replace it with alpha in that entire formula, and I want you to simplify it for the next 2 minutes.
All cosine alphas?
Nope, you're just going to replace beta with alpha. That's all you're doing.
All we're doing?
So plug the alpha in, and I want you to simplify, and I want to see it on your paper that you're actually showing steps to simplify that. And do some simple math to simplify. It won't go very far, but I want to see what you get and why it's that, and we're going to talk about it. First, good?
Cosine. Fish. Times sine fish. That's going to go to sine fish squared.
Sine fish squared.
Sine fish squared. And that's going to be cosine fish squared.
Minus cosine fish squared.
How does this look? Cosine. That's going to be 2 cosine fish. Mr. Warren, I think I got it, as Hall would say. Let me break it down in quadrants. I got it.
Sine fish times that's negative sine fish squared.
Mr. Ward, this is 2 cosine fish minus cosine fish squared minus. Yeah.
Minus? No.
It's not the 2. This is just cosine plus fish. Cosine, oh, it's cosine 2 fish.
Fish.
Cosine fish squared.
Now you gotta figure out what you can do.
You don't have to do it that way. That's not how. Hey, what are you doing back there?
You guys haven't done it yet? Nope. Have your notes up? Be driving this?
I just got back, so I'm just getting interested.
I agree with all of us. The shoes are in the wrong spots, but you can just split this.
Man, we got caught in the storm every single time.
We're going like front of the equals. Yeah, you simplify that. Good. I agree with all that.
He's like, you can go up there. I was like, yes. And then he goes and puts
We're replacing all the alphas or all the betas with alphas.
You describe it as a human, probably not. You definitely can do it.
yeah, but
Simplify your. So far, so good. You've written it down correctly.
The most I've ever had as a squad was 24.
Slightly.
but me,
Okay.
I got 18.
Hey, I'm going to give you another 30 seconds or so. It looks like everyone's kind of wrapping it up. And then I'm going to call on a couple of people to tell me what they have written down. And I'm going to bounce around the room. So try not to overstep somebody because I'm going to call on random people to see what they got. And then we're going to talk about it. Because I want to discuss how to use it and what it is. And then we're going to get to other ones today. Why I start with this one. This one technically has 3 different formulae to it. You have found one of them. We'll talk about how to find the other 2 later.
Let's substitute in beta for alpha.
No.
For fish.
For fish.
No.
Fish.
No. Okay, let's start right off the bat. Okay, Johnson, I want to know what did you write down in the very beginning? No. The very first part you were right.
So you need to fix those betas.
Okay, and what do I have to change them into?
Alpha.
Alpha. So what do you have written down?
All I did was erase the beta and put an alpha sign.
Okay, so you're going to be quite literal. All right. So, so what she did originally, the first start when I was talking in the room, she immediately put alpha. She erased everything, put alphas, and that's exactly what I wanted. This is what I wanted to see on your paper.
What if I didn't write that?
You should.
What if I just like shorten it?
Yep. That's what you should have in the first part.
Okay, I have that. I lied.
Second part. Okay? I'm going to jump over to Reese. What do you get on this side only?
Cosine.
Cosine?
2 fish.
2 fish, or 2 alpha. Oops, hold on. Cosine, 2 alphas. Now, here's why. When you're adding alpha plus alpha, it's like adding x plus x. There's 2 x's, so there's 2 alphas. Lots of talking today for something new. All right, on the other side, Let's go to the other side here, and I want to jump over to, I think it was, let's go over to, Josie, what do you have on that one side over here?
Like, after all of this?
Yeah, after this side, so you simplified it a little bit. What do you have?
Cosine squared theta
Good.
minus sine squared theta.
It was alpha.
Sorry,
Not big.
whatever.
Yeah,
You know
I know what you meant. Alright,
We put the square in the front, not the back of the alpha.
it's got to be in the front of the alpha, not behind it. So that's another thing, because,
Parentheses and put the square on the back.
no. So, now, hey, the only way that that could be written correctly is if you did this, Nicole. If you wrote it like this, cosine alpha with a square like that, that's fine.
That's what I did.
Okay, all right. But the only thing I was worried about when you said that is if you did something like this, where you put the square on the alpha with the parentheses,
No,
that would be a no.
I have it on it. Is
All
that
right.
because we squared the alpha and not the cosine or alpha?
It's got to be on the sine, not the alpha yet. Okay. Waiting people out here.
Thank you.
Goal today is to talk about how to use this. This is the formula for double angle for cosine. It's one of the three that we're going to be getting. This formula is different in such a respect that how we actually use it, what it actually means. What I'm talking about here is if you're doing a problem like, let's say, now this can be a very easy problem. If you had your unit circles in front of you, you could rattle off the answers, but I want to talk about how it's used. Here's the idea. Let's say we're doing a problem like cosine of 120. I know this is silly because it's on our property sheet, but this is a double angle. It is twice as big as an angle that we know how to solve. What I mean by that is this part right here, this 120, is literally double a 60-degree angle, something that we've done previously.
We can do that?
Yeah, we can actually, instead of doing addition problems every time, or just rattling off like what 120 is from a unit circle, let's say you didn't remember what they are, because you don't have the unit circle memorized, or maybe you don't have it in front of you. But you do have, maybe this is printed on the top of a test. You could use the double angle formula to help you out. What I mean by that is that we're taking 2 times 60, and 60 is technically the alpha in my formula. So it's this part. So what I can do is instead of using alphas, I could use 60-degree angles here.
Since we're using cos.
And so this is cosine of 60 degrees,
Which is
squared.
Squared out. Minus.
We're going to subtract
Minus root 3, 2.
sine of 60 squared. Now, here's how you would actually solve this type of problem. You would actually have to have the special triangles for the 30, 60, 90. 30, 60, 90, which is root 3, 1, and 2. And we would actually plug those answers in, and it would actually give me the correct result. What I mean by that is the first step. Hey, we're going to find the cosine of 60, and then we're going to square that answer.
It's half.
Okay, so whatever the cosine of 60 is, we're going to square it.
Half squared. 1/4.
So cosine of 60 is the adjacent wall over the hypotenuse wall. So half, like we were saying, but we have to square it. So cosine of 60 is half. We're going to square it, and then we're going to subtract sine of 60.
Root 3 over 2.
And we're going to square that. So sine of 60 is the opposite over the hypotenuse. So root 3 over 2, and we're squaring that. And what this answer is, when we actually simplify this, it will actually give me my answer for the cosine of 120 without having to go to a special, without having to go to the unit circle or using a reference angle in that second quadrant. So 1/2 squared is 1/4 because you square top and bottom numbers. When you square root 3 over 2, you get 3 over 4. And then you subtract and get -1/2.
So and then it's 6.
Because you can actually subtract negative 1/4. I mean, not 1/2, but negative 1/4. Negative 2/4, which is negative half. There we go. But this problem here, why that's important? That's the exact answer for this without having to use the unit circle, without having to do reference angles in that second quadrant. It actually can, the reason why we can do this, we can do really weird and obscure angles now, because we can do halves of them, and we can do double angles from them, which is really unique. It's just one of those things that it's a different style of problem, but we can actually solve for more angles now. Like for instance, when we had 75s, right? I know a lot of the times last week, some of the problems that were in the book, they used cosine of like 75s. Those angles, we can eventually use some form of this, some form of a double angle to actually solve it. And that's what we're going to be eventually getting into, how to do double angles and half angles and all that. But the goal today was to show you where the formulas come from and how to use it. This is exactly how I'd use this type of problem.
So you said that we're not going to be able to use our little units. We can't use that.
That thing eventually, no.
This is so helpful.
Well, for the homework it's used, and it's quite helpful for homework. And for driving formulas it's going to be used.
But no test. We can't.
Possibly no.
That means yes, you can. Just let us know. I could. Mr. Ward, does this apply to non-Euclidean geometry?
Yes. Based on curves, so yes.
What is a real-world use for this?
Finding the lengths of the walls for a triangle that has 120 degrees and obtuse triangle. And so now if you had certain wall lengths, we can now actually find like the hypotenuse wall, the adjacent walls, the opposite walls, because we actually have what the exact answers are for them. And cosine stands for adjacent over height. And if I had one of the walls of my triangle, let's say like you had ground or you had the hypotenuse, you can find the missing wall in that triangle, even though it had 120 in it originally. We can now actually solve for it, which is really nice. Alright, questions so far?
There's more?
Oh yeah, we got a lot more today. If you guys keep talking, we're going to have more and more and more.
So is tomorrow the work day?
Nope. I may not give you work day if you guys keep talking.
Okay.
Let's derive some more.
Okay, next one I want you to put on your paper. Sine. Alpha plus beta. So we're just doing the sum formulas for right now. So if you use that little property sheet that you have, the little handout thing we made last week, the formula for sine of alpha plus beta, sine of the first, cosine of the second,
Plus
sine of the second, cosine of the first. So the idea is that we're doing sine of addition formula, but we're going to manipulate it in such a way that we can do the double angle formulas for it. So here's what I'd like you to do. Replace all the betas with alphas again. Write it down, simplify it with some basic math, and I want to see what you come up with.
Okay, I get it.
Good. Already heard it correctly so far.
Wait, correctly in this fish?
Okay, you have everything down correctly so far.
Yeah, I should do 2 before and 2 after.
The word is this is similar to what it needs to be.
That's exactly what. What?
So you're saying you don't better do.
Nope.
What the heck?
Write it down? We have replace all the betas with alpha.
I did that, but yeah.
So it's sine
You got that? This side
cosine 2
should
fish.
simplify.
Yeah, same.
Oh, we go through it, even though it's that,
Just write it down.
just like
Yeah.
this.
Alright. On the other side.
Sine 2
What do you
fish
got?
equals cosine 2 fish.
So that's not
Oh,
that.
just say
Those two will multiply
cosine
together.
2
So you have
fish
sine.
equals
Oh,
cosine 2 fish.
that's what you do it.
Sine fish, cosine fish.
So now.
Because he said we're doing fish.
Oh.
So I have
I
the
said
same.
parentheses.
So the hell.
You have to know about parentheses?
So,
Ours is just.
You should have something on the left side.
I
Ours is
noticed
like
it, I
more
got it.
intellectual. Yours is just.
I agree with that. I don't agree with that.
Fine.
Not many things we do that.
Yeah, but it
How about
works.
this? No, it doesn't work, Corey. You're fake news. Fake news.
Can I explain?
You are fake news.
Oh, no,
No,
seriously.
you cannot explain.
You are fake news.
No,
Don't
don't go back on your what you said.
Sine.
Don't let her explain.
Then you have cosine plus cosine.
Cosine plus cosine isn't cosine 2.
This
You
was
have
like
this.
Miss Sloan,
sine,
this
you
is
have
the correct
cosine plus
answer.
cosine, which the 2 would be up front.
Oh, so then that's,
That's
but now you agree.
wrong. You just did it wrong.
Wrong. I agree with what you have there, but not what you have originally.
Right there.
Wrong.
Yes, so far so good.
You are fake news.
Is that all I can do?
I'm not gonna
Give you one more second.
What else?
Wrong.
Wrong. Wrong.
You are fake news.
Oh my gosh, you're making this over now. I don't get it.
Wrong. You only have one thing. That's one.
Remember when you said one through the first one? She said I had it like this, he said I was wearing kind of like that. It's supposed to be right hand, two of them, not two ends.
Well, I have to look for it.
He said it up there on the
I
first
got that.
one. He just said you wanted it there.
Oh, because I can find it over.
Go destroy it.
And then I went to my phone and sent that message and you said, I got 100%.
I don't know how I can simplify it more.
Hey, I need to use echo. You're like, okay. And then you just kept going.
There's no way to simplify it.
One more
Does
second.
she
You
not,
rearrange.
does she not have one? Just a matter of
Corey's
All right.
fake news. In other
Hey,
words,
here we go.
fake EWS.
Alright. Dalton. Dalton. Walk me through what you have written down so far.
Sine. 2 fish.
Yeah. 2 alphas. Now, stop there.
Oh, okay.
Okay, why did you have 2 alphas written there right away?
Oh, because you got fish plus fish equals 2 fish.
Yeah, it's x plus x equals 2 x's. Well, when you use alphas, alpha plus alpha is 2 alphas. Alright, keep going.
Then you got an equal sign. And then you got a 2.
2.
And then a parenthesis.
Okay, keep going.
And then you got sine, fish, cosine, fish, parenthesis.
Alright, and you put the parentheses in there if you like. Now, this is what you should get. Let me explain, because you are absolutely correct. It's just a rearrangement. Here's the idea.
I see that as 2 sine, not 2
When you replaced all your betas,
I think the parenthesis. They put fish in.
hey, when you replaced all your betas, you had all the alphas plugged in. These items were being multiplied together. This is one item. It's a single monomial. Even though there's multiple items on it, it's a single monomial. This is a single monomial, and when you add them up, you have to add the leading coefficients together. That's why you get 2 of them. 1 plus 1. It's kind of like a variable. Think of this like a W, so it's 1W plus 1W, which is 2 Ws. That's the idea. This formula right here is the one you should have written down somewhere on your notes, if you have not already. Now, why would we actually do this? So let's say we're doing a double angle. Let's say we're doing the double angle of, I'll just kind of make up one, this is going to be silly. Let's go sine of 90. I know that we could use a unit circle and rattle that off. But what this actually stands for, sine of 2 times 45 degrees. It's a double of 45. And we can actually use this to actually solve. This is 2 sine of 45 times cosine of 45, because it's a double angle formula.
And we don't have to do that. And we don't have to do that like 30 or 45 thing.
Nope, not on this one. We have to use a 45, 45, 90 triangle.
Okay, no, 30. 50 minus 4.
So for 90 degrees, I separated the 2 times 45. I separated the 45s using my formula over there. And 45 degrees for cosine and sine, they're all the same answers. It's opposite over hypotenuse, adjacent over hypotenuse, and here's what you get. A lot of people talking for me never having explained this before. So we have the 45s plugged in. We multiply straight across, and notice I didn't simplify these because when I multiply straight across anyways, they're going to simplify each other. It's going to be 1 over root 4 when you actually multiply those two parentheses together, which is 1 over 2, because the square root of 4 is 2. And when you actually multiply it by 2, I get the answer of 1. And that's why when you actually look at your unit circle and you find 90 degrees, and you look at the sign is the second answer on the unit circle, there's a 1 sitting there. This is actually the math that explains why it actually works. Why you're getting certain numbers the way you are. Especially if you don't know how to read off some of the values for the trig functions, this is a really great way to figure them out. Alright, last one today. We're going to do the tangent double angle. Some people have already started it today. We're going to do the tangent double angle, and we're going to, from there, it's like tomorrow we're going to do half and power reducing.
Already served. Toa? Water's actually already inside of that.
Okay, I'm going to leave this on the board for right now. Here's what I like to do on your paper. I'm going to walk around the room. I want to see you take the tangent alpha plus beta formula. And I want to have you do this on your own. I want you to replace all the betas with alphas and simplify that formula down. It won't go very far, but I want to know what it is.
That's it.
And I want you to simplify it down. You have to look up the formula yourself in your little handout, plug the alphas in, simplify it as far as you can. I want to check to see if your math is correct. I think you guys are done. And then we're going to do an example of it, and then we're done for the day.
Is that a fact?
Yeah.
So this is only going to work with like angles that it's like...
No, we can do this for any type of angle. We can like double it. So the idea is that you're thinking, okay, well we can only do this for 30, 60, 90, 45, 45. But the problem is like, eventually what we're going to get, we're going to mix this with some of the other ones, because we can do like 75, right? Because we can split 75 into 40 stuff. And the idea is that we can take those, we can double those as well. Like we're going to be mixing like a ton of stuff together actually. So this is the start. Is talk about how we can do just a simple double angle. We're going to do weird ones, like scissors.
Geometry really made me think, you know. Parallel lines do not exist.
Yeah, it's pretty much just take it.
I don't know.
That's it. I don't know, right? It's 2 tan fish equals 2 tan fish divided by 1 minus tan fish. 2 tan fish equals 2 tan fish. 2 tan fish equals 1 minus fish tan. So that makes 7. Did you know the last white African rhino is about to die? Yeah, it's on Death Watch. Because he's old as crap.
Yeah, but like, why are you like?
The only thing I would probably question is putting a square root in the back. That's what it's not. Right over the tangent. Put it behind the variable. So it should be squaring the variable and not.
Look it up.
Yes.
The white rhino.
All I know is he's about to die, and you're like, he's almost dead.
He's the last of his species.
That's right.
Mr. Ward, how do you feel about the white rhinoceros about to die?
Sad.
Did you know about that?
Why can't you just find a blue, like a different rhinoceros?
There is a like
You can't make two. It's reproductive.
Why don't we clone him?
You take a cat and a horse. You make a horse, and then you can't make it work the horse size.
Okay. Put a square after the tangent.
Yeah, but mules are
Okay.
infertile.
Yeah.
You can breed several things together.
I'm not fixing it. Not fixing it.
Hey, did I tell you about the
giraffe
baby fish that I got?
I'm thinking more like a whale
That's how I
and
got
a
ice
cheetah. So like these really
So, yeah,
fast
the name is
amphibious creatures
and it's for
that
guys.
can
I thought
run 90 miles an hour on
What
land
color?
and swim like a
Like,
big
it's kind of
whale.
like a red tail and fins, but like
I would
silver
turn
body.
myself into a
Like
whale.
blue eyes, it's really nice.
Hey, pictures. I want to see pictures.
Okay.
Okay. Hey. Hey. Last one today. All right. Last one. Let's do the tangent. It looks like a lot of you had it. I'm gonna go to Lucas. I want to hear what you had written down because it was correct. Walk me through it.
Where?
Right here. Just walk me through it.
Tan to fish.
Okay. Tangent. Hey. Shh. Tangent. 2 fish. All right. Keep going.
Tan fish plus tan fish.
Okay. Agree. Tan fish plus tan fish.
Yes. You can simplify that Dan. Plus shame.
Over. Keep going.
1 minus tan fish times tan fish.
Good. All right. Now, let's talk about, this is the generic formula of plugging in the actual alphas, right? You get to this point. He's absolutely correct. He has the right formula written down. He has all the alphas and the betas correctly, interchanged and whatnot. And he has the right formula because he was doing the plus, so the plus is on the top. Okay. Let's keep going. I'm going to jump to the next person here. Let's go to Kyle. What was your next line that you guys had written?
So the candy fish, but then the 10.
Yep. Yep. Keep going. So tangent 2 alpha equals what's on the top over here?
Tangent to alpha.
2 tangent alpha. Over. Keep going. There you go. Okay. Hey, here's your last step. You have the 2 tangents on the top because you can add them together to get 2 tangents. On the bottom you have tangent squared. Now, again, why we can use this? It could be for any angle that you're doubling to make, a larger angle. So let's say we're going to do I know this is going to seem a little weird. We could do like a 240-degree angle because you're doubling a 120. And we could have the 120 in here, and then that's a double of another one. So we can take really big angles like 240s and break it down by whatever the double angle formulas are. So we go down to 120s or go down to 60s, and we can break them down further and further and further by doing double angle formulas one after another, which is a lot of work. Let's just start with a very easy one though.
60.
Yeah, let's do 60. That'll work. All right, we'll start there. That's a great one to start on. All right, tangent. Tangent is 60. Okay, gentlemen, since I hear you guys talking, you can walk me through it.
Alright.
Tangent is 60. What is that the same as?
Tangent 60. Well, we have to do these tangents.
It's the same as tan squared.
Nope. Use my formula. Since you guys are talking, I figure you know what you're doing.
Oh, we could do 30s.
30s. Tangent, 2 times 30. Keep going.
Equals.
What does that equal to?
Tangent 30 plus tangent, or 2 tangent 30.
Connor Burke, come to the office. I'm sorry, Connor Keesh, come to the
Over
office. please.
1
Connor
minus
Keesh.
tangent squared 30.
Okay? Alright, so far so good. We're doing 60 degrees, which is double of 30. And now the last thing we have to do, what's your tangent of 30?
Oh, opposite over adjacent.
Can you draw the special triangle?
Yes.
Oh, I couldn't see.
1 over square root 3.
1 over root 3.
1 over square root 3. Now you gotta get the square root out of the box.
Get rid of it.
Throw it up your way.
Yeah, I agree with that top one. We definitely don't want to have that radical on the bottom. We'll try to simplify it here in a minute, but what's the bottom going to turn into?
1 over 3.
Yeah, it's 1 over 3 because you squared both. You're absolutely right. This is 1 over 3. When you actually square that, because radical will go away, the top is 2 over root 3, which we'll simplify here in a minute. Because when you multiply by 2, the 2 goes to the top. And then we'll have to simplify from there.
So then it's
2 over root 3 keep going, I hear it.
2/3.
Say it again?
2/3.
2/3, because this is technically 3 over 3, and you're absolutely right when you subtract, you get 2/3. And the next step, what do we do? Flip it. Reciprocal. So we're going to multiply by the flip of the bottom, which the 2's would cancel, leaving me with
3 over root 3.
3 over root 3, which simplifies. Because you put the radical on the top, you get rid of the radical off the bottom, and your answer is just root 3.
Wait, how did you just multiply by 3?
Yep, multiply by radical 3's top and bottom.
You multiply by root 3. You multiply by root 3.
And hey, here's the idea. Why that answer makes sense. Because what was my original angle?
60!
Tangent of 60 is opposite over hypotenuse, or opposite over adjacent, which
So
is
is there
root
always
3.
going to be that one?
No!
Alright.
That's awesome. So you literally just let